Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. We've recently launched our Patreon page, which can be found at cynicaldeveloper.com/Patreon. If you aren't familiar with Patreon, it's an easy way for those who are interested in this show to help out by simply pledging a small amount each month in sponsorship. Now that could be as little as $5 a month, which is about £3.80, or as much as you like. You will enable us to dedicate more time creating more content to help you, including videos, more blog posts, and even more shows. So if you can, head over to cynicaldeveloper.com/Patreon and get involved. In this episode, we cover the solid principle with Steve Smith, or as some of you will know him, as Ardalis. Steve is an engineer and software developer with a passion for building quality software as effectively as possible. He has published several courses on Pluralsight covering DDD, Solid, design patterns, and software architecture. Steve is a Microsoft ASP.NET MVP and insider, a frequent speaker at developer conferences, an author, and a trainer. Steve works with companies that want to avoid the trap of technical debt by helping their teams deliver quality software quickly. Steve and his team have been described by clients as a force multiplier, amplifying the value of existing development teams. Steve's client list includes Microsoft, Quicken Loans, Selena Insurance, and many other satisfied customers. So welcome to The Cynical Developer, Steve.
Thank you. I'm glad to be here.
Yeah, thanks for taking some time out from your very busy schedule.
Yeah, I'm glad we were able to get this set up.
Yeah, I think it's nice. And you're a fellow podcaster as well, and your show is it's called Weekly Dev Tips. Do you want to explain what your podcast is about and how often a new episode comes out?
Sure. I started it about 6 months ago, and Weekly Dev Tips is my podcast where I just describe a short tip. Takes about 5 or 10 minutes for each episode. There's not interviews or a whole lot of other fluff involved. It's pretty much short and to the point, with the idea being that you could kind of fit these episodes in between the other podcasts that you might listen to that have a longer format. So there's about 20 of them out there now, and as the name suggests, they're aimed to be weekly, although in practice I end up skipping weeks from time to time. But my hope is in 2018 to put out about 50 of these episodes.
Awesome. Yeah, I am a subscriber to it, and I do listen. And I think at the time of recording this one, you are covering design patterns, which is an interesting one for me.
That's right.
Cool. And today we're going to pick up on something that I said in the introduction that you've done on Pluralsight, which is talk about the solid principle.
Yes. The solid principles are really fundamental to object-oriented programming. So if you're a C# or a Java developer or some other object-oriented programming developer, it would be great for you to have a good understanding of these principles and to know when and how to apply them to your code.
Yeah, definitely. It definitely is. Where does this, before we get into the nitty-gritty parts of it, where does the solid principle come from, and why do we need it?
So it's a set of 5 principles. Solid itself is an acronym of acronyms, which I think is called a macronym. And so each of the other principles, there's the single responsibility principle, or SRP, the open-closed principle, OCP, and 3 others we'll get to. They, for the most part, were derived by various computer scientists over the last, 30 years. And they were put together and coined as solid by Uncle Bob Martin. He described them all in one of his earlier books, Agile Principles, Patterns, and Practices of Software Development. I think I got the last part of that title wrong. It's a really long title of that book. But in that book, he didn't have them in the order of solid. He didn't coin that term. I think Michael Feathers is credited with rearranging the order of them to create the word solid. And then Uncle Bob has called them that in later books of his, like Clean Code, I think uses solid as the name. So they've been around for a good while. Some of the principles are credited to folks in the industry from the 80s. Like the Liskov Substitution principle, which was coined by Barbara Liskov.
Sure. Yeah, it's one of those terms that people will probably have heard of, might not really know what it is, may be following the pattern of it, but don't realise that they are. So if they're doing TDD, they're probably doing the vast majority of it already. But if you go to a lot of technical interviews, it's something that you're going to be asked about. In my experience, it's normally tell me what each of them are and a quick overview for them, and that's what I'm hoping to sort of address in today's show. Is just we'll get a rundown of them, an explanation for each of the different points.
Sure.
Cool. So let's start at the beginning for a change with the S, which was single responsibility.
That's right. So the S in Solid is the single responsibility principle. And the single responsibility principle basically states that your classes should only have a single responsibility. And Uncle Bob Martin, Robert Martin, writes that you can think of this as saying that your class should have only one reason to change. I sometimes give presentations on Solid, and when I describe single responsibility, I often poll the audience and see like what do they think of as a responsibility, and sometimes you'll get answers like, well, I've got a class that's responsible for customers and another class responsible for orders, and that's the responsibility in my class is broken down like that. And so you ask a little bit more like, well, what do you mean it's responsible for orders? And like, well, it describes the property of an order, and it can save an order and validate an order and print a report of orders. And they list off like a dozen different things all related to orders that this class can do, which in my head I'm imagining is about 1,000 lines long.
Yeah.
And that's not quite what the single responsibility principle means, because if you have a class like that, even though conceptually all the things it's doing have to do with orders, there's all these different ways that class might have to change if any part of your system changes. For instance, if the way you do data access changes, you'll have to change the orders class. If the way you want to handle describing orders changes, you'll have to change that class. If how you're doing reporting changes and you've got all your reports driven by that class, you'll have to change that class. And so the way you follow the single responsibility principle is you break apart the different responsibilities in terms of pretty low level and isolated things. So if you want to validate the order, that's a responsibility that should be in its own class. If you want to be able to print them, that's another responsibility, et cetera. Data access should almost certainly be in a separate class from other concerns, especially business logic, in your application. So right off the bat, when you follow the single responsibility principle, even if you don't follow any of the other principles, this means that you're probably going to have smaller classes that each do one thing and do it well. And so you'll have in your project structure, if you're not used to following these principles, you're probably going to have more files than you used to. You're probably going to have more classes than you used to. And you're going to need to maybe adjust the way that you work inside of your environment to make it so that you're productive dealing with more classes. That's often one of the pushbacks that folks that are unfamiliar with Solid have, is that they don't like the fact that they used to have a program that had 10 classes in it that were each 1,000 lines long, and now they have a program with 50 classes that are each 50 lines long, and that requires a different way of reasoning about or looking at your application. But it turns out to be much more maintainable when each one of those classes only does one thing.
Sure. Is it one of those things where you have to get to a certain point with it and say that'll do? So you said there that your data access should be a single responsibility, but should you be chopping up your data access into single responsibility classes, so you end up with a class that does your reading, one that does your writing, one that does your deleting, that sort of thing? Or would you just group those all together?
In my experience, the way to approach this is to follow. There's a sequence of writing code that Kent Beck, I believe, wrote, which is that when you're trying to implement some feature or fix some bug in your code, you should follow these 3 steps, which are make it work, doing whatever ugly code you need to write, then make it right, meaning refactor the code to make it better. And then the third one, if you ever have this problem, you should make it fast. Right? If it's fast enough after the second step, then don't worry about it. And so when you're following that type of approach, the first thing you should do is just solve the problem. And if that means adding another method to an existing class and making it bigger and kind of increasing the scope of some class and adding another responsibility, then fine, go ahead and do that. Make the code do what it's supposed to do, and then step back for a moment and look at it and say, okay, is this code in this class, is it cohesive? Are the operations all related to one another and kind of performing at the same level of abstraction? And does it look like something I could easily maintain and change if I needed to, given what I expect to come as future requirements? And if all of that looks good, then you're good. Ship that code. But if you're looking at your code and you're seeing that there's a whole lot of duplication, or there's a whole lot of places where you can kind of see technical debt accumulating in the application, and it might be any of the things that I mentioned, like there could be duplication, there could be different levels of abstraction mixed together. If you start to see that, then you can take that as an opportunity when you're doing that refactoring step to clean that up. And one of the ways you might choose to clean that up is by pulling out some group of methods that are more related to one another than they are to everything else in the class, and putting them into their own class. And this would help achieve the single responsibility principle.
Sure.
What I don't do, and what I don't recommend anyone do, is try and follow every principle out of the gate in every possible way, because you're going to end up with this code that doesn't do anything and is just nothing but a whole bunch of abstractions that is like infinitely flexible but not productive at all.
Totally. And you end up somewhere back towards Waterfall where your execution is perfect, but you never actually end up with a finished working, finish is the wrong word, a working product at any time to ship.
Right.
Cool.
If you go look online, you'll find folks that have tongue-in-cheek implemented the Hello World program, following every best practice and solid principle. And of course it's hundreds of classes that are all abstractions of factories of other things, and it's a mess, and that you can certainly take all these things too far, which is why I recommend that you start out by just solving the problem, and then step back and see if you can clean up the code as you go, working in small steps.
Sure. And then we're moving on to O next, which was open and closed.
That's right.
Which I believe is open to extension and closed for modification.
That's correct. And so the open-closed principle, as you said, it suggests that your code, your methods, your modules should be open to extension but closed to modification. And what that means is that you should be able to extend their behavior or change their behavior without having to modify the source code. And the simplest way to think about this is if you have a method, let's say, that saves a file, does some work and saves something to a file. If you hard code the file name into that method, and then later on you want to save that file somewhere else or with a different name, the only way that you can change that is if you go into that method, change the string of the name, and then recompile and rerun that method. So it is not closed to modification, and nor is it open to extension, at least on that front, because the only way to adjust that behavior is directly in that function source code. A very simple way to make it open to extension and closed to modification would be to just pass in the file name as a parameter. And in fact, most of the ways that we achieve the open-closed principle is through some use of a parameter, either on the method or on a class constructor. And so by adding that parameter, you make it so you now have a much more flexible solution. You have a method that can now write to any file, and you can adjust that behavior of which file to write to without having to recompile or edit that method itself.
Sure. So we've got the extension there of these objects. Now, what is meant by that extension is that I can go in and add new methods on there. I can add new overloads and things, or is it because I think, at least for .NET developers, it can get very confusing on that one, because you are able to extend classes and things like that. to what extent does extension mean?
When I think of it, I generally only think of it to mean the behavior and not necessarily the structure of the object itself. So it doesn't really matter whether it's C sharp, where things are strongly typed and generally you're not able to dynamically add behavior to a method. It's more about the fact that you can extend how that method works and what it's able to do without having to recompile the guts of that method itself. Now you can achieve that same extension of behavior through different techniques in an object-oriented language. So in addition to passing in a parameter, another way that you might achieve it would be to use inheritance and say I'm going to override that method and change something about how it works in a base or in a child class that then calls into the base class. So there are different techniques, but the technique isn't so much important to the principle as the notion that you should be able to change the behavior if you need to for those behaviors where it's important that you be able to change them. And again, this comes back to you can't prematurely optimize for every possible way that you might extend a particular method. If you do, you'll have a mess of abstractions in your code. So generally what you want to do is, the first couple of times that you see that a method is having to change in response to customer requests, you go ahead and you just make the changes. But by the time you're on like the third one, you maybe can recognize that this is a method that's going to keep changing. It's likely that I'm going to continue to see the need for this method to grow or change or whatever. And so I'm going to apply some kind of a refactoring to allow it to follow the open-closed principle.
Sure. Okay, good. And I think, for me, the next one is probably the most elusive of the five, just because it's not that obvious from the title of it as to what it exactly is, and that's the Liskov Substitution principle.
Right. Yes, and this is the only one that's got the person who came up with it in the name of it. So the Liskov substitution principle can be summed up as saying that objects that inherit from another type must be substitutable for that type anywhere that the system would try and use them. And so if you have ever used a type where you inherited from some base type and you didn't need all of its functionality for your purposes, and so maybe you had several methods that you just said, throw new not implemented exception, which is, the default behavior in C# when you implement an interface or an abstract class. That class, by definition at that point, doesn't follow the Liskov substitution principle, because if some other developer or future you comes along and sees that you've got this implementation of this interface or this base class, and they have a need to use it for one of its methods, and they just plug it in, and they don't look at your implementation details, they're going to be surprised at runtime when the thing blows up with a not implemented exception. That's sort of the easy, obvious case of violating this principle. There are certainly trickier ones. One of the ways that you can recognize that you're not following this principle is when you are writing some code that's taking advantage of polymorphism, which is where you can treat types and their child types as being the base type. The easiest way to think about this is where you have a for each over some collection of things. An example I like to give is you have a collection of employees. And some of those employees are simply the employee base type, and some of them might be special kinds of employees, like a manager employee or an executive employee.
Yep. And
you're doing something inside of this for each loop where you want to, let's say, print them out. And so you have a special method for printing out the executives that's different from the method that you use to print out employees. And so inside your for each loop, you say, well, if employee is executive employee, or we use the is keyword in C# to check its type, then I'm going to call this one special method for how I want to deal with it. Else, I'm going to call the regular method that prints employees.
Sure.
That if check is a smell. It's telling you that you're not following Liskov substitution, because you shouldn't need to know whether or not that particular instance of an employee is a base employee or a child of that base type. And the result of not following Liskov is that you end up with that kind of if logic kind of scattered throughout your application. It won't just be probably in one for each loop. It'll be in several for each loops, or it'll be in several methods that otherwise shouldn't need to care about which type of employee they're dealing with.
Cool. So yeah, you would need to implement a factory or something in there that automatically works out what type of employee that is, whether it's a base employee or a management employee, and then return the printed value, whether that's a string or whatever it is, in the correct format that method, that loop is expecting.
Yes, yeah. There's any number of ways you could do it. That would certainly work.
Sure.
You could move the printing capability into the type itself and just call, employee.print. You might violate single responsibility principle at that point, but it would let you solve the Liskov substitution issue. Another thing to think about is that in .NET, and like many other languages, we have the support for null. And when you have nulls in your system that you're dealing with, they are also a violation of the Liskov substitution principle, if you think about it. So if, let's say I had the case where I was going to move that print functionality onto employee, and then I would customize it, accordingly. If I for each over a collection of employees, and then inside of there I just call employee.print, that'll work now for every different type of employee, whether it's a manager employee or an executive employee, unless that collection happens to have a null in it, in which case it'll blow up and give me a null reference exception.
Yep.
And so I'll end up having a conditional that looks almost exactly like that is check, except instead of checking if employee is, executive employee, I'll check if employee is not equal to null and do something different. Or I'll say if it is null, print something different. And so you get the exact same code smell when you have nulls involved in your system that are going to break your polymorphism, as you do if you have types that don't fully implement their base types. So keep in mind that nulls break polymorphism.
Yep. Yeah, sure. On to the next one, which is on interface segregation.
That's right.
Yep.
The ISP is the interface segregation principle. And the interface segregation principle basically says that client code should not be forced to depend on behavior or methods that it doesn't use. And so the corollary to this is that you should prefer thin, cohesive interfaces to big, fat interfaces. One example I give when I give talks is back around 2005 or so in ASP.NET, Microsoft shipped the membership provider, which was an identity system for ASP.NET that lets you register and log in and forget your password and all that sort of thing. And their membership provider that you had to implement if you wanted to customize it yourself, because theirs only worked with SQL Server. So if you wanted it to work with Active Directory or Oracle or whatever else, you'd have to write your own. To implement it fully, you had to write something like 30 or 40 methods. It was rather large.
Yeah, I do remember that that pain.
Right. Yeah, it was definitely painful, especially since it did everything and included the kitchen sink in that interface. And most implementations, in my experience, didn't need all of those bells and whistles.
No.
A lot of the time, all you really cared about was register, log in, log out, and forgot password. And the other 30-odd methods that were there, you didn't need. So if you implemented it, you probably implemented it with a whole lot of not implemented exceptions, and you're breaking the Liskov substitution principle at that point. If they had factored that type into smaller providers, like just a login provider or just a registration provider or what have you, it would have made it a lot easier for their clients to consume just the bits of it that they required. One nice thing in C# where you have interfaces, interfaces support multiple inheritance of other interfaces. So if you find that you have a large interface already in your system and you have types that already depend on it, and you're working in a class that only needs 2 methods from that larger interface, as long as you own that interface, you can create your own smaller interface that just has the methods you need, and then change the definition of that larger interface so that it no longer has those methods that you're requiring, but it inherits from your smaller interface. And so that will continue to compile just like it did before, because at the type level, that interface is no different, whether it had those two methods on it directly or whether it inherits them from your small interface that just has those two methods.
Yeah, and that breaking out of interfaces into smaller interfaces is one that I've had a debate several times with different people when I've been working with the likes of data layers, and I've had a save, a load, and a delete interface, separate ones, because you have certain types of data that maybe you want to load and maybe you want to save, but you never want to allow the data to be deleted, and it always seems to be a hot topic for one reason or another. Out of all the different points within Solid, that's one that I've always ended up having to defend a little bit more.
Yeah, and it's one that you can kind of do it when you need it, but also it has value in the flexibility that it affords you in some of your optimizations and architectural choices down the line. So speaking again specifically about data access, there's two common ways that you can increase the performance and scalability of your data access. On the read side, you can usually increase performance by introducing caching. And on the write side, you can often increase scalability and performance by introducing some kind of an event queue or a command pattern where you don't actually do the write immediately. You just record a command that says to do the write, and then some other process actually does the write.
Yep.
If you split your data layer, your repository implementation, not necessarily into update and delete each one of those totally separately, but if you just split it between reads and writes, then it makes it very easy for you to implement those types of things on just those methods that need it. Because it doesn't make any sense to use an event queue for a read operation, and it rarely makes much sense to do any sort of caching on a delete, right, or an update. Although you might choose to update your cache or invalidate your cache in that scenario, you're not typically going to add the actual cache in that case.
Yeah, and I think you're talking about the CQRS pattern with
exactly.
That.
Yep. Main query responsibility separation.
Yeah.
And that's there's a bunch of different benefits if you follow that. But one of them is that it makes it easy for you down the line to introduce these optimizations for performance reasons to your application.
Cool. And we're finally at the last one, which is dependency inversion principle.
Correct. Yep. The dependency inversion principle has two parts. It's a little more verbose in its definition. And it basically says that you don't want your types to depend on the implementation details. You want them to depend on abstractions. And you also don't want the way that your code, the low-level implementation details, you don't want your abstractions to depend on your low-level implementation details. You want those to depend on abstractions. So let's break that down because I didn't do a very good job of explaining it. What that means is that first of all, your code that is doing the low-level work. Let's say you have a method that's responsible for saving a record to the database. That method is fairly low level, right? It knows about the database. Let's say you're using SQL Server. It's got dependencies on ADO.NET and SQL Client and things like that.
Yep.
And it's writing using ADO.NET directly into a SQL table. That's fairly low level. It's definitely coupled to your infrastructure and the way that you're going to store data. You don't want your business classes and your higher level classes to depend directly on that lower level class. So you wouldn't want to have an order class that's in your business layer talk to something that was the data access layer for order and call some save method on it, so that now at compile time your business level order class has a compile time dependency on this data access layer class that talks to the database. Instead, you want your order class to only have a dependency on some abstraction, and that abstraction in C# is going to be an interface typically. And so you would probably call that interface these days a repository. So you might have an iOrder repository that has a save method, let's say, and you would use that interface to save an order to the database. When you do that, you won't have any knowledge of whether or not you're calling to a SQL Server database or calling to the file system or calling to Oracle or calling to some web API. All of that is hidden behind the abstraction. The second part, which is that your abstraction should not depend on details, means that if you write an interface for doing, let's say, data access, and instead of saving, let's talk about reading an order now, or a list of orders. You want to make sure that your interface doesn't depend on details either. So if the underlying details of your implementation is that you're going to use a SQL data reader to fetch rows of data from a SQL Server database, you don't want your interface to return back a SQL data reader. You want it to return back a list of order or an IEnumable of order or some other, standard .NET framework type that is a collection of orders. Because if you return back something specific to your implementation detail, like a SQL data reader or like an XML document or something like that, now your implementation details are leaking into your abstraction, and it's going to make it so that anything that tries to use that abstraction is now tightly coupled to that implementation.
Yep. Yeah. So everything should be talking to interfaces, and then you should be somewhere in your code, probably up in your front end, somewhere, telling your code base which implementations to use through inversion of control.
That's right. And the dependency inversion principle is very closely related to the other DI, which is dependency injection. And so when you follow the dependency inversion principle, you will often use dependency injection to inject into types the implementation of whatever interface that they have said they're using. And so, like you said, at the startup of the application, at the entry point, typically, you'll do the work of defining the actual implementation types you're going to use for your different interfaces, and then all of that stuff will be used to basically construct the object graph of your application. And you can do all of that manually and just by hand and just instantiate everything up when the app starts. But for most business applications these days, you can use some kind of a dependency container, an IOC container. If you're using .NET Core, which is what most of my work is using these days, there's a simple built-in container that's part of ASP.NET that you can use. Otherwise, there's a host of various open source DI containers that you can use.
Yeah, and at the start there, I mentioned about the fact that if you're doing TDD, then you're probably more or less following a lot of these rules already. If you're not, then the test-driven development that you're doing is probably lacking somewhat, because your tests are going to be leaking out everywhere into using concrete types rather than using their abstractions and things like that. So all of these different principles that get bandied around quite regularly are all interlinked, and you do use them day to day, even if you don't know that you're using them. And hopefully, this show has helped you a little bit down that path. We've done a little bit on BDD, we've done a show on TDD, and now we've done this show on Solid. So hopefully it's starting to build up that foundation knowledge for you. And there are so many other principles and patterns and things that we can talk about. We could go on for days and days about the different ones. Hopefully, this might become a recurring theme for the Cynical Developer. We'll start talking more about these, as well as all the cool new tech that's coming out as well. We're just about out of time as well for today's show. We've covered off Solid there in a solid way. I think, and I personally have a better grasp of what Solid is, and I hope everyone else out there does. So I'd just like to thank Steve for coming on and talking through it with us.
Yeah, you bet. Thank you. I'd be happy to come back again sometime.
Awesome. Yeah, it'd be great. And if somebody wants to go and find out more about these, you've obviously authored a lot of stuff on it. Do you have blogs and things as well that people can go and look at?
Sure. I've got some stuff on my blog at ardalis.com. I also cover the principles briefly in a reference site that I run called deviq.com. And I have a course. It's actually one of the more popular courses on Pluralsight, which is the Solid Principles of Object-Oriented Design. So I'd encourage people to check that out. It has a bunch of concrete examples of how to take code that doesn't follow Solid and refactor it so that it does follow the principles. And you can see how that makes the code easier to test, easier to work with, and easier to maintain.
Sure. Awesome. We'll get some links in the show notes for that. So thanks again for coming on and talking to us.
All right. Thank you.
Thank you. And thanks to everybody out there for listening to Cynical Developer. I'm James Sludart, and you've been listening to Steve Smith talking about the Solid Principles. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help the Cynical Developer to reach more developers around the globe.